All right, let's dive right in. Today, we are breaking down a fascinating article that makes a pretty bold claim that we've been building AI all wrong. And get this, the key to fixing it lies in something you're literally doing this very second, reading. So just think about it for a second. What's actually happening in your brain when you read a simple word, like fire? You don't just see the letters F-I-R-E. You might feel a little warmth. You might picture a campfire. You might remember the smell of smoke. It's this incredible, instantaneous alchemy that turns symbols into a full-blown experience. And the big question our source material poses is this: can AI ever truly do that? Well, this whole process, it actually has a name: semiosis. It's not just a dictionary lookup. It's a living, breathing dance between a sign, like the word fire, the actual object, and your personal interpretation. Meaning is created on the fly. And according to this idea, if we can get AI to understand that dance, we can solve one of its biggest, most fundamental problems. Okay, so let's get into the heart of the problem. The article calls it the approximation trap, and it's the core reason why even the most advanced AI today can't understand things with the same certainty that you or I can. To really get this, the article uses this brilliant analogy it calls the cake problem. So picture this: a master baker shows you the most magnificent cake you've ever seen. It looks incredible, it smells amazing, but when you ask for the recipe, they just shrug. They have no idea. The entire process was a complete black box. And that's exactly what we're trying to do with what's called explainable AI, or XAI. It's like a team of scientists tasting that finished cake and trying to guess the recipe. They can analyze the flavors, the texture, they might get kind of close, but it's always reverse engineering. It's always a guess about what happened inside that black box after the fact. Now, here's what that looks like in math terms. Pretty much all current AI operates on this formula. Y is approximately dx. Y is the answer, and dx is all the data and the complex model. But the most important part of this whole equation is that squiggly line in the middle, the almost equals. That's the trap. It's a mathematical admission that the AI is always just approximating. It's making a highly educated guess, but it's a guess nonetheless. It can never be 100% certain. So how in the world do we get out of this trap? Well, the source we're looking at proposes something really radical. It's not just a tweak or an upgrade, it's a completely new formula, a total rewrite of the fundamental rules of AI. And here it is: y equals d times m. Now look closely. That squiggly, uncertain approximation sign, it's gone, replaced by a hard, definitive equal sign. And we have a new variable, m, which stands for an explicit map of meaning. This changes the entire game. We've just jumped from the world of probability to the world of certainty. So here's what that shift really looks like. On the left, you have the old way, that kind of tangled black box approach. But on the right, you see this new, elegant architecture. It cleanly separates D, the atomic definition of a thing, from M, its map of meaning and all its relationships. It's the difference between making a guess and just looking up the answer on a map. Okay, so to make a formula like this actually work, you can't just use the same old parts. You need entirely new building blocks. It means moving away from what current AIs use, called tokens, to something much, much more powerful. And the difference here is just night and day. Current AI tokens are basically just fragments of words that get turned into numbers. But these new things, called tokens, are designed from the ground up to be verifiable units of meaning. The real takeaway here is that you're shifting from a system that is fundamentally probabilistic and opaque to one that is deterministic and totally verifiable. So what exactly is a token? Think of it as a token of universal meaning. It's like a single, permanent, universal address for any given concept. So the Spanish word gato, the English word cat, and even a photograph of a cat would all point to the exact same unique, cryptographically verifiable token. It's a direct line to semantic truth. And packed inside every single token is its semantic DNA. This is like a library catalog card on steroids. It doesn't just name the concept, it holds its core identity, how it relates to every other concept, where the information came from, its authoritative source, and its exact location in the entire web of knowledge. It's completely self-contained, auditable, and traceable from end to end. So, what happens to the world when an AI moves from just guessing to actually knowing? Well, the consequences are absolutely massive. This isn't just about building a better AI. It's a paradigm shift that could make a huge chunk of what we're doing today totally obsolete. The biggest change is how the AI gets an answer. Current models use next token prediction. They are, and this is the important part, literally guessing which word is statistically most likely to come next. This new system uses next token selection. It doesn't guess at all. It simply navigates that explicit map of knowledge to select the correct verifiable answer. It's navigation, not prediction. And this leads to at least 3 immediate, mind-blowing consequences. First, that huge, incredibly expensive process of AI training, it becomes obsolete. You don't retrain a model with 1 trillion parameters. You just add new, verified knowledge to the map. Second, things like RAG, retrieval augmented generation, become totally unnecessary. Why would you need to retrieve a document when the AI already has all the knowledge explicitly mapped out? And third, the cake problem we started with? Solved. Explainability isn't something you try to add on later. It's baked right into the architecture from the very beginning. And if all that wasn't enough, the system can retrieve knowledge in what computer scientists call O of one time, or constant time. Now, what that means is frankly incredible. It takes the exact same amount of time to find one fact in a single book as it would to find that same fact in the entire Library of Congress. Every piece of knowledge becomes instantly and directly addressable. You see, this is about so much more than just building a smarter machine. An architecture like this has the potential to fundamentally rewire our entire relationship with information and kickstart a brand new knowledge economy. The way it's envisioned is as 3 interconnected layers. You've got a global brain, the Comprehensive Comprehension Cloud, or CCC, holding all of humanity's public knowledge. Then a layer for organizations, called Shared Semantic Systems, or SSS. And finally, the most powerful part, your own personal perspective portal, or PPP, a truly personal AI that understands your context, your history, your perspective, without ever having to compromise your privacy. And this whole system enables a profound economic shift. We could move away from today's extraction economy, where our data is harvested and we are the product, to a new contribution economy. Imagine a marketplace where your expertise, your insights, your knowledge has verifiable value. Contributors would actually get compensated every time their knowledge is used to construct an answer. Think about that for a second. You get paid for being right. It completely inverts the entire business model of AI as we know it. So, we're left with this really powerful final thought. The article argues that the future of AI, the real path forward, isn't about piling on more data or building bigger models. It's about building a deeper, more robust architecture of meaning. It's a fundamental shift from approximation to precision, from guessing to knowing. And the final question isn't whether we can build it, but are we ready to make that leap?